Water heaters are massive, heavy, and filled with dozens of gallons of scalding water and gas. To save floor space, homeowners often banish them out of sight, hoisting these cylinders up through a narrow wooden hatch and into the rafters. Up there, the environment is brutal. It's an unventilated, severely cramped crawlspace where summer temperatures can easily exceed 130 degrees. The first sign of trouble usually isn't water dripping through the ceiling. It's a sound, a low, continuous popping noise coming from inside the tank, right around the time the burner kicks on. It sounds exactly like rice burning on the bottom of a hot stove. That popping is the sound of water boiling through a thick, hardened layer of calcium. Because the unit is trapped in the attic, routine maintenance like annual flushing gets ignored, allowing heavy sediment to accumulate on the floor of the tank. Eventually, the system gives up entirely. The pilot light goes out. The main burner refuses to ignite, leaving the house without hot water. The attic atmosphere actively degrades the machine, while the physical hazards of the space make simple maintenance a genuine risk. To understand exactly why the heater died, we have to look at its internal engineering, specifically its primary safety device, the thermocoupling. This animated diagram shows how the system works under normal conditions. A pilot flame burns constantly against the metal coupling. That heat generates a tiny, continuous electrical current. That microcurrent travels down a wire and acts as an electromagnet. It provides the exact amount of power needed to hold a spring-loaded main gas valve firmly in the open position. But up in the attic, the system starves. The extreme ambient heat and severe lack of oxygen create a deeply smothered environment. Without fresh oxygen, the burner cannot breathe, causing heat to build up inside the combustion chamber rather than venting away. This localized overheating, combined with the 130-degree ambient air, stresses the thermal link until the material physically cracks. The heater is now securely locked down. The gas supply is severed, and it cannot restart without a human physically replacing the broken components. The conditions inside a tight attic are completely incompatible with the heater's engineering. The harsh environment guarantees that this crucial safety mechanism will eventually fail. Fixing that cracked coupling means a mechanic has to go up and face the exact environment that destroyed it. The physical space is severely restricted. A plumber can barely sit up, let alone stand, and often has to work just 3 feet away from the open ceiling hatch, where a single misstep means falling straight down the ladder. Because there is zero room for proper leverage, removing the old gas control valve requires getting creative. Plumbers frequently have to thread the flexible gas pipe itself into the valve, using it as a makeshift wrench to break the assembly loose. Relieving pressure from the full tank carries an immediate risk. As the old valve comes off, water will inevitably spit out. The mechanic has to carefully jam a sponge into the opening to catch every drop, keeping water from flooding the combustion chamber underneath. Then comes the challenge of working entirely blind. To prevent gas leaks, the mechanic has to bend over and push a small rubber grommet firmly into the combustion chamber seal, entirely by feel. In these conditions, the mechanic must perform a routine fix while perched precariously over an open hatch, where a single slip leads to a fall or a flood. Once the new valve and coupling are installed, the system has to be manually restarted. The mechanic must press and hold the gas knob down for a full minute, forcing the pilot flame to heat the new metal and generate enough electrical current to hold the main valve open before the burner finally kicks back on. Even a successful repair takes a massive physical toll. Sweating through temperatures that climb rapidly as the day goes on, the mechanic leaves the cramped space, battling severe heat exhaustion. The root cause of all this trouble is psychological. When heavy machinery is tucked away in the rafters, it creates a persistent out-of-sight, out-of-mind mentality. Because accessing the unit requires climbing a ladder into a sweltering crawlspace, homeowners inevitably skip the yearly flushes, allowing the calcium to build and the airflow to stagnate. Trading a few square feet of hallway closet space to hide a water heater in an attic is a false economy. It guarantees neglected maintenance, suffocates the very components designed to keep you safe, and eventually forces a high-stakes repair right above your head.